remaining quadrilaterals and their properties. Okay, so we're going to cover several remaining ones. With trapezoids and kites are the last two. So let's start with some definitions here really quickly. Parallelogram is a quadrilateral with two pair of parallel sides. If you only have a one pair of parallel sides in a quadrilateral, it's called a trapezoid. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. Okay, and as far as what you see, you have base angles. Okay, so each pair of angles on a trapezoid from the parallel lines are called base angles. So here with this base, the bases are the two parallel sides, and then the angles that are formed on those bases are called base angles. Now there are going to be some relationships that we'll talk about a little bit later on with those. The other thing to keep in mind regarding a trapezoid, and again I'm just going to kind of redraw this, here's your parallel sides, is if I label base 1 and base 2, the height of a trapezoid is that perpendicular distance between those two parallel bases. And this gives you the area formula for a trapezoid. And the area formula for a trapezoid is 1/2 the sum of the bases times the height. So this is the formula that you would use. And now, if for some reason you forgot that formula or you needed to derive it, what you could do is you could create or recreate this trapezoid into two triangles. Here's one triangle here and a second triangle here. And if we took the area of triangle 1, would be 1/2 the base of B1, and the height, again, this height would still be perpendicular distance. It's still the same given height here, h. And if we found the area of the second triangle, it would be 1/2 the base, which is B2, times its height would still be that same h value. And so think about what you're doing here. If you add these two triangles together, you would get a 1/2 B1 H1 plus 1/2 B2 H. And if we removed our common factors of 1/2 and h, we'd be left with B1 plus B2. And notice here is our formula. We just reorder and put the bases in front, but 1/2 times the sum of the bases times the height is your area formula, or you could break it down into two triangles and add their areas independently. So the area formula is 1/2 the sum of the bases times the height of the trapezoid. That is your formula. And so if you plug it in, 1/2 times, here's our parallel sides are the bases, so 6.4 plus 16. It doesn't matter which order you put those. And then the height of that is this perpendicular, which is 12.8. And there is your answer if you enter the calculation for this. 1/2 times the sum of the bases times the height, and you would get 143.36 for that calculation. Now, I mentioned we'll talk about base angles again, and that happens when you have what's called an isosceles trapezoid. An isosceles trapezoid is exactly what you would think of it, based on it being, or the word isosceles triangle. An isosceles trapezoid is a trapezoid with congruent legs. Okay, so you have a base, and then these are called legs. If the legs are the sides connecting the parallel bases, if those are congruent, then you have what's called an isosceles trapezoid. Okay, so the first set of properties that we're going to look at are true only for, or specifically for isosceles trapezoids. Okay, so let's take a look at that. First is that their base angles are equal. That should make sense, right? Because if you were to extend an isosceles trapezoid until those two legs intersect, it would be an isosceles triangle, and the properties of an isosceles triangle is those base angles are equal. So if you have an isosceles trapezoid, the base angles are congruent. Okay, so here angle A is congruent to angle D, which because of same side interior angles, angle B and angle C would also be congruent. Okay, so both of those pairs of relationships would exist. Okay, and so the converse of this also holds true. Okay, if you have a trapezoid and it has a pair of base angles that are congruent, then that means that it is an isosceles trapezoid. Okay, so if one pair of base angles is congruent, then you know that, it is an isosceles trapezoid. That would give you the property that these legs would be equal. A, B, and C, D would be equal. You would also know that angle B and angle C would be equal as well. And then the final relationship here that we're looking at is if you do have that isosceles trapezoid, the diagonals are congruent. And so here they're using this biconditional, if a trapezoid is isosceles, or a trapezoid is isosceles if and only if its diagonals are congruent. Okay, so if you have an isosceles trapezoid here, then that would mean that BD and AC are equal to each other. All right, so let's take the properties, and again, a trapezoid is also a quadrilateral, so the sum of the angles is 360, but it's also parallel lines, so the same side interior, or consecutive interior angles holds true. So I want you to just really quickly try this first question here. See if you can find all the remaining angles given the one angle D of this isosceles trapezoid. Base angles are the same. So if D is 21, that means C is also 21 degrees. And you have these consecutive interior angles, CIA, of parallel lines. So those are going to be supplementary. So if we took 180 minus 21, and that's going to give us our answer of 159. And if angle A is 159, then that means the other base angle of that isosceles triangle, or that isosceles trapezoid, is also going to be 159. So here you have your remaining three measures. Okay, you may also be given a question where you're just being told you have this isosceles trapezoid. What would X have to be for this to be true? Well, if that was the case, then these two angles, base angles C and D, would have to equal each other. And so if you set those expressions equal and solve for the resulting equation, so if we add x to both sides and add 12 to both sides, you get 12x is equal to, when you combine these, 60. Divide by 12 gives you an x of 5. Now, once again, remember, you need to determine, are you being asked to find the angle or are you being asked to find x? Here it wants the value of x, so our answer would be 5. Do keep in mind that if it was asking you for the angle, you would take 48 minus 5, or you would take 11 times 5 minus 12. 55 minus 12 would also be 43. So you make sure that you're answering the question that's specifically being asked. All right, try this last question on your own. Here you're being told that this is an isosceles trapezoid. What value of x would make the diagonals equal, which is that condition for the isosceles trapezoid. Okay, so there's several, or if you have a quadrilateral with congruent diagonals, A rectangle is one example of that, right? If it's a parallelogram with congruent diagonals, you have a rectangle. If it's a parallelogram and it has congruent diagonals, then it's isosceles, or sorry, if it's a trapezoid with congruent diagonals, then it's an isosceles trapezoid. So here AC and BD would have to equal each other for this to be the case. And so if we take the expressions for each of these, x minus 6 and 54 minus 3x, we can move everything to one side. Let's move the constant or the variables to the left to make them positive. We'll add 6 to both sides. We get 4x is equal to here 60. And if we divide by 4, we get x is equal to 15. So there is our value for x. Again, if it had asked you to specifically find the length, 15 minus 6 would equal 9. And 54 minus 3 times 15, which is 45, would also equal 9. So if it was asking you to find the actual length of the diagonal, you could, but in this problem, it's asking you to determine the x value. All right, the last concept dealing with trapezoids that you need to be aware of is also one that we saw with triangles, and that is the midsegment. Okay, so remember, the midsegment of a triangle is parallel to and half the length of the base of that triangle, and it connects the midpoints of two sides on a triangle. A similar concept or similar definition for the midsegment of a trapezoid. And so let me define it here first. And so if you have the midsegment of a trapezoid, it's going to be a segment that connects the midpoints of the two legs. Okay, and so here, if M and N are midpoints, you can see from the tick marks that that's the case, then that means that MN is the midsegment. And the midsegment theorem states the following. The midsegment of a trapezoid has two conditions. Much like the triangle, it's parallel to each base. And then the second condition is that it is the average of the two base lengths. Okay? And so it's half the sum of the base lengths. Okay, so again, half the sum means it's the average of the bases. Okay, and so when you are looking to calculate this, just from the standpoint right here, is that MN, since you can see from the tick marks that it is a midsegment, it's going to be parallel to these sides, the two legs or the bases of this trapezoid, and it's going to equal 1/2 the sum of those. So that means that if we took 15 plus, we'll call it x here, just to give it a variable, we know that if we took that and divided by 2, we get our midsegment length, which is 36. And so it's just a matter of solving the resulting equation here. Multiply by 2. And when you solve, subtract 15 from both sides, you get your x value here to be 57. You can enter it as a calculation or that specific calculated value. All right, so see if you can kind of extend this same concept here to expressions and find out what's not only what is x, but then what are the lengths of PQ and SR based on that relationship. All right, so think about, again, this same relationship is if you have the segment connecting midpoints of the two legs of a trapezoid, it is a midsegment, which means it is parallel to these remaining bases, and it is 1/2 the length of that side. So what we see here is that 31 is equal to 1/2 the sum of x plus 5 and 8x plus 39. Now, notice I'm going to go ahead and regroup each of these here to indicate. When you're working with fractions, you always have a choice. You can distribute or you can multiply both sides to get rid of your fraction. So to me, right here, if I'm thinking about distributing this 1/2, because I see an odd number, an odd number, an odd number, I mean, like, well, actually, let me go through and let me combine these terms first. So if I'm working with this, to me, it's easier to just multiply by 2 to get rid of the 1/2 than to try to distribute it through. But let's take a look at sort of the steps of this first. So before I decide that, let's combine our like terms. In here, I get 9x, and here I get plus 44. So notice if I distributed my 1/2, I would end up with a fraction here. I really don't want to work with a fraction. So instead of distributing the 1/2, I'm going to multiply both sides of this equation by 2, the reciprocal, right? And so when I do that, 2 times 31 gives me 62. And here the 2 times 1/2 cancels, so I'm just left with the expression 9x plus 44. Go ahead and solve the resulting equation here. So if I subtract 44 from both sides and divide by 9, I get my x value to be 2. That's one of my answers, right? It's asking me what is the x. And once I have the x, it's then asking me what's PQ. So PQ is 2 plus 5, or 7. And you could have also written that as a calculation, right? You could have said 2 plus 5. And then RS, we could have said 8 times 2 plus 39. And if you did this by hand, you would get 16 plus 39. When you combine these, you would get 55. And so that would give you your 3 answers for the parts of that question. All right. So the last 2 quadrilaterals that we are looking at today were trapezoids and kites. So that's trapezoids. The final quadrilateral is a kite. And depending on which textbook you use or how far back you go, so like more ancient textbooks, thought of kites and parallelograms like kind of differently, or kites, parallelograms, rectangles, rhombus, squares. They thought of those as being like not falling into multiple categories. But for the purpose of this course, we're going to say, or we are using the definition that a kite is any quadrilateral with 2 pair of consecutive congruent sides. So notice here's 1 pair of consecutive congruent sides, and here's a second pair. Okay, so that's what makes up a kite. Okay, now let's take a look at several instances. Okay, what do we call this quadrilateral? 4 congruent sides is a rhombus, right? Okay, does a rhombus have 2 pair of consecutive congruent sides? Here's 1 pair. Here's a second pair. So yes, so a rhombus is a kite. Okay, because every property of a kite will work for a rhombus, okay, we are defining that. A rhombus will be a kite. Okay, what about a square? Well, a square is a rhombus and a rhombus is a kite, so would it make sense that a square is also a kite? Yeah, here's 1 pair of congruent sides, here's a second pair. So a square is also a kite. And when we talk about the properties of kites, those properties will also work for both a rhombus and a square. If you recall, we had the area formula of a rhombus where it's 1/2 the product of the diagonals. It also works for a square because a square is a rhombus. So you can have these like multiple categories of things, but not all kites fit these 2 conditions. These are very specific instances of kites where they have that. Right, so the area of a kite is 1/2 the product of the diagonals. This is exactly what we saw when we did the rhombus. Because a rhombus is a kite, this area formula worked as well. And so when you are looking at the area of a kite, you have one diagonal, a second diagonal, and your total area. Again, the kite has congruent sides here, congruent sides here. Your area is going to be 1/2 the product of the diagonals. Now, let me talk really quickly about some properties of a kite. We're going to maybe get to them a little bit on the next slide. But when you have a kite, these diagonals are perpendicular to each other. The diagonal that connects the 2 points where the non-common sides intersect is bisected by the other diagonal. So this segment and this segment are congruent. And then for the other diagonal, again, what it winds up being is just that whole length. But what you see here is that you have 2 congruent triangles here. You have another pair of 2 congruent right triangles here. And so that property, again, if you needed to, you could break this area down into those separate shapes, or you could use this whole triangle and double it. And you can break it down if you need to. But the 1/2 product of the diagonals is the easiest formula to use. Okay, so just really quickly, calculate this first problem. And can you find its area? Remember, you can enter your answer as a calculation. One-half the product of the diagonals. D1, it doesn't matter which one you choose. So I'm going to use 33 as D1. D2 is 24. There's my answer. If I did the calculation on this, 1/2 times 33 times 24, I get 396 for that area. Remember, these are square units. Again, area is a 2-dimensional measurement. You don't have to enter that anywhere. Again, just keeping you up to date on what the sort of proper units would be for a 2-dimensional measurement like area. All right. The final slide is just going to go through some of those properties that I sort of highlighted here. I'm going to talk about in a little more detail. Okay, first, when you take a kite and draw in the diagonals of a kite are perpendicular. So these intersect at a 90-degree angle. Again, not only that, but this diagonal connecting the non-common sides is being bisected. So this would be 3 tick marks each. And then the last thing would be when you are looking at a kite, because if you look at this triangle formed right here, you have a congruent triangle. The mirror image of that is the other half of that kite. And so it should make sense that these opposite angles here, C and A, are going to not just be corresponding, but they are going to be exactly the same. So in a kite, exactly one pair. So opposite angles are congruent. Okay, and that's this pair. So angle A is congruent to angle C. And now, again, if you were drawing this diagonal is going to bisect these angles because they are forming congruent triangles here. So keep that in mind as well. All right, so see if you can use those properties here to answer all these remaining questions. Just take a moment. See if you can answer these questions. They all involve specific measurements, not expressions. Okay, but can you put them together with those properties? All right. let's go through these. Again, I kind of wanted to be done by 2:30. Okay, so if we start with the one on the top right. Okay, so if we're told that EG is 56, that means that when you are looking at these measurements, here's EG. We know that the diagonals are perpendicular to each other, so EDF is 90 degrees, the right angle. And we see in here that this diagonal is being bisected. So that means that if we took 56 and cut it in half, we have each length, which would be 28 for the length ED in this example. Okay, if we move straight down and look at that problem, here that angle where the non-common sides intersect, these are congruent to each other. So that means if this angle is a 90 degrees, this one will also be 90. So H is 90 degrees here as well. And now to find angle G, we go back and you need to use the idea that you have a quadrilateral. The total sum of the angles in a quadrilateral is n minus 2 times 180, okay, or 360 degrees. And so if you took 360 and subtracted the two knowns, or the three knowns, 90, 94, and 90, you would get your answer for this. And so if we took 360 minus two 90s and a 94, we are left with our answer of 86. All right, the final question here, same idea as what we just did. These are two non-common, the intersection of these non-common sides. So those are congruent to each other, which means we can call each of these angles x, and we have that same relationship, right? The sum of all of these, so x plus 36 plus x plus 110 is equal to 360. And if we just start combining what we have, so 2x is equal to 2x plus 146 is equal to 360. Subtract the 146 from both sides. When you do that here, you get 214. Divide by 2, and you get your answer. 214 over 2 is 107. So that means each of those angles is 107. They're going to be the same thing here, so we'll enter that answer 2 times. Now again, you could have done your calculations directly in that answer box as well.